All right, let's take a look at the practice test. For the instructions, we're asked to find the transformation from f of x to g of x. All right, for problem 1, we have f of x equals the absolute value of x, and then g of x equals the absolute value of 1/3 x. So when I see a problem like this, the first thing I would try to do is rewrite my g of x in terms of f of x, and then just think about the formulas that we learned in the lesson. So I see that for this guy right here, I have the absolute value of 1/3 x. And then for this guy right here, I just have the absolute value of x. So this right here, this 1/3 x is being plugged in for x in this function f of x. So in other words, I could say that g of x is equal to f of 1/3 x. Now that we've written it like this, we can use our little formula that we talked about in the lesson. So when you have something that's on the inside of the function, remember, these are the harder ones to think about. They're a bit counterintuitive. You have to think about, how could I undo what's being done to x? In this particular case, you have 1/3 that is multiplying x. So how do I undo multiplication by 1/3? Well, I would want to multiply by 3. 3 times 1/3 is 1, and then 1 times x is just x. So when you multiply by 3, you're getting a horizontal stretch, again, because it's on the inside, by a factor of 3. Again, don't think about that 1/3 and just take it as a given. You have to undo what's being done to x on the inside. So let's say that there's a horizontal stretch by a factor of 3. All right, a good way to think about this, if you're struggling with it, is to go to an online graphing calculator like Desmos. I have a link that's provided to you for every problem. So you just click on that and everything's already labeled for you. So you'll just be able to work with the points. What I'm going to do is label this first. So this graphing, let's just call it green. This is f of x is equal to the absolute value of x. This graphing, let's call it red. This would be your g of x is equal to the absolute value of 1/3 x. Let me make this 3 better here. When we think about a given point on this function, let's just pick this one. I think it's easy to work with. This right here is 3, 3. So in other words, f of 3 would give me 3 because the absolute value of 3 is 3. Now, where is this point going to go on this function g of x? Well, I said that there's a horizontal stretch by a factor of 3. In other words, what I am saying is that for a given y value, in this case, the y value is 3 for this point right here, the x value now needs to be multiplied by 3 when compared to this f of x equals the absolute value of x. So you have a 3 here, multiply that by 3, you're going to get 9. So this point right here is going to be 9, 3. See how this right here is being horizontally stretched? And you can plug in and see what's going on. You're basically going to undo the multiplication by 1/3 to get yourself back to where you have the absolute value of 3, which would give you 3. In other words, g of 9 would be equal to the absolute value of 1/3 times 9. This would be equal to, well, this, again, would cancel with this and give me a 3. So I'm right back to that 3 that I plugged in the original function. So g of 9 would be equal to the absolute value of 3, which is 3. See how I had to take this x coordinate and multiply by 3 to get this x coordinate that would give me the same y value. Here the y value is 3, here the y value is 3, but the x coordinate here had to be multiplied by 3 to produce that. So you can use that link on Desmos to play around with this a little bit more if you want. I really suggest that if you're struggling. Now, let me address something else. This is something I talked about in the lesson. So quite a few people leave questions about this and they'll say, hey, I saw your answer was a horizontal stretch by a factor of 3, but when I look at the graph, it looks like it's vertically compressed. Well, remember that you can algebraically manipulate this. You could say that g of x is equal to the absolute value of 1/3 times the absolute value of x, that's completely legal, which would be equal to 1/3 times the absolute value of x. Well, if I write it in this manner, let me move this over here like this, well, now I would use a different formula. I would say that in this case, your g of x is equal to 1/3 times f of x. And when we see it like this, we would say there's a vertical compression by a factor of 3, or again, there's different ways to say it, different terminology. Your book might say that there's a vertical shrink by a factor of 1/3. It doesn't really matter how you say it. It's personal preference. It's really just understanding that for a given x value, now the y value is going to be 1/3 of what it was, or divided by 3. So for example, let's just take this point right here, and let's think about it that way. So this point right here is 9, 9. So it's 9, 9. So for that given x value, now the y value would be 1/3 of what it was, or again, you could divide it by 3. So 9 times 1/3 is 3, or 9 divided by 3 is also 3, however you want to think about it. So you look at that point right there, this would be, again, the same x value of 9. The y value is now divided by 3, so this is 3. So if you had thought about it this way, and you gave an answer where you said it's vertically compressed by a factor of 3, or you said it's vertically shrunk by a factor of a third, again, different terminology, same meaning, well, essentially you would also have the right answer. But what I would do is I would stick to, in this section, just going with the way that the problem is presented. So in this particular case, we get this on the inside, so that's how I would answer. I would give the answer as a horizontal stretch by a factor of 3. All right, let's take a look at problem 2. So here we're given f of x equals the square root of x, and g of x equals 1/2 times the square root of x. So again, I'm just going to go with the way that the problem is presented, and I'm going to rewrite g of x in terms of f of x. So I'm going to say that g of x is equal to 1/2 times f of x. So what is this doing? For a given x value, the y value has now been multiplied by half, or you can say divided by 2. So you can say that there's a vertical compression by a factor of 2, or again, you might want to say there's a vertical shrink by a factor of a half. Just different terminology, it means the same thing. Just go with your personal preference, or if you're in a class and you're following a teacher, just use their terminology. I'm just going to put that there is a vertical compression by a factor of 2. So for a given x value, the y values are being divided by 2. Again, if you want to come to the graph, this guy in green, this is going to be our f of x is equal to the square root of x. And then this guy in red, this is going to be our g of x is equal to 1/2 times the square root of x. In other words, it is 1/2 times f of x. And again, for a given x value, the y value has now been divided by 2 or multiplied by half. So this point on the original square root function, you have 4, 2. So 4, 2. And again, if you look at the point here on your g of x equals 1/2 times the square root of x, well, now the x value is the same. So it's still going to be 4, but we are dividing the y value by 2, or again, multiplying it by half. So 2 divided by 2 is 1, or 2 times a half is 1, however you want to think about that. So this would be 4, 1. And again, you can see that with this point right here, this is 9, 3. And then this point right here, this is 9, this would be 1.5, just taking 3 and dividing it by 2, or you could say 3/2 if you want. So again, for a given x value, the y value has been multiplied by a half, or divided by 2. So you could say that there's a vertical compression by a factor of 2, or again, a lot of people say a vertical shrink by a factor of a half, however you want to answer. All right, for problem 3, we have f of x equals x cubed, and then g of x equals 1/3 x, and this is being cubed. So again, we're just going to go with the way the problem is given to us. So I'm going to say that g of x is equal to, this is on the inside, so I'm going to say it's f of 1/3 x. Again, how do I undo what's being done to x? This is 1/3 on the inside that I need to undo, so I would multiply by 3. So this is another one where you're going to have a horizontal stretch by a factor of 3. So in other words, if you want to come down to the graph, and this one right here, f of x is equal to x cubed, and then this guy right here, this is your g of x is equal to, so this would be inside of parentheses, this is 1/3, and then x, and then this would be cubed. Let me fix that 3 there. So for a given y value, let's just take this one of positive 8 here. Well, on the original function, your f of x equals x cubed, you can see that that is going to be 2, 8. So this is 2, 8. Well, how do I get that same y value in my g of x function? Again, I've got to undo what's being done to x. How do I undo multiplication by a third? I've got to multiply by 3. So this guy right here, you would need 2 times 3, that would give you 6. So now this point is going to be 6, 8. Again, if you were to plug that in, and you did, g of 6, well, that's going to be your 1/3 times 6. You're plugging that in. This would be cubed. So what is 1/3 times 6? Well, that's going to be 2. It gets me right back to this x coordinate here. So let's cancel this and show this. You would have 2 cubed, which would give me 8. So that's all it is on the inside. You need to undo what's being done to x. And in this case, you would multiply by 3 to do that. So it gives me a horizontal stretch by a factor of 3. All right, for problem 4, we have f of x equals, this is my greatest integer function with x as the argument, and then g of x is equal to 3 times. This would basically be, again, the greatest integer function with x as the argument. We can see that we can really rewrite g of x as being equal to, you just have 3 times f of x. And so this is just a vertical stretch by a factor of 3. That's all it is. So a vertical stretch by a factor of 3. All right, so graphically, if you want to look at this, again, in computer science, we really call this the floor function, but you can also say it's the greatest integer function, so f of x is equal to, the notation for this is going to vary, so I'm going to just use this. Kind of hard to draw it, but I'll just say it like that. So this is your greatest integer function. I want you to remember how this works. So let's just pick any of these. So let's say that I'll do x and y here. I'll just do a few of them. If your x value, so x is greater than or equal to, let's say 1, and strictly less than 2, well, the y value is going to be 1. So that's what produces this right here. Again, the x value is from 1 and including 1, going up to and excluding 2. You get a y value of 1 always there. Then you're going to step up. So if the x value was including 2, going up to and excluding 3, well, now you get a y value of 2. Let me put this one in. So x is greater than or equal to 2 and less than 3. Now it would be 2. You can keep going. So x is greater than or equal to 3 and less than 4. Now you would get 3. So on and so forth. So when we look at this guy right here, it's just 3 times this guy. So in other words, this right here, your g of x is equal to, just put a 3 out in front. So 3, and then we'll make that little notation there, which I'm not so good at doing. But basically, you're just vertically stretching by a factor of 3. So if you look at this over here, well, now if x is greater than or equal to 1 and less than 2, the y value would be 3. So you see that. This is an x value including 1 going up to and excluding 2. Now the y value is 3. If you looked at this one right here, so we did an x value of 2 and including that going up to and excluding an x value of 3. Well, again, the y value here is 2. Well, you've got to multiply by 3. So you're going to go up here to where the y value is 6, so on and so forth. Again, I gave you a link for it if you want to play around with it on Desmos. This one's a little bit harder to think about because it's not a function that we're used to working with, but just spend a few minutes with it and I think it will make sense for you. All right, let's take a look at problem 5. So here for f of x, we have 1 over x. And for g of x, we have 1 over 2x. Again, this one is kind of tricky to think about. Well, am I doing g of x as being equal to 1/2 times f of x? Or am I doing g of x as being equal to f of 2x? Again, how you want to answer is up to you. Both answers would be correct. It's just how you want to interpret the problem. I'm just going to go that g of x is equal to f of 2x like this. And I'll probably give both answers when we get to the graph, just showing you an alternative way to think about it. But this right here would give me a horizontal compression, right? Because again, if it's on the inside, I have to undo what's being done to x. So 2 is multiplying x there. To undo that, I need to multiply by 1/2, or I can divide by 2. So it's a horizontal compression, you could say by a factor of 2, or again, some people will say a horizontal shrink by a factor of 1/2. I don't care about your terminology, just understand that for a given y value, you're now going to have to divide that x value by 2 or multiply by 1/2 to get that. So let's say that this is a horizontal compression by a factor of 2. Let's go to the graph. Okay, so for this one, the points are a little bit smaller just for how close things are. But again, you can go to Desmos if you need more detail. The graph in green, this is f of x is equal to 1 over x. And then the graph in red, this is g of x is equal to, you have 1 over 2x. So think about for a given y value, the x value has to be, again, you could say multiplied by 1/2 or divided by 2. So let's go right here. This point is 1, 1. And I did that terribly. So let me redo that. So 1, 1. For that same y value, again, on this function right here, g of x equals 1 over 2x, notice that the x value has to be divided by 2 or multiplied by 1/2. This point right here, let me arrow to it. Again, these notches here are in terms of 1/2. So this is 0.5, 1, 1.5, so on and so forth. This x value right here is 0.5. So this is 1/2, 1. So to get that same y value of 1, when I work with g of x, the x value that produces that is going to have to be 1/2 of what it was here. So again, you can play around with more points if you want. Now, another way to think about this, let me erase all this. You could have really written this g of x as being equal to 1/2 times f of x, because that would really be 1/2 times 1 over x. Let me write that out. So you could really say that this is 1/2 times 1 over x. And at the end of the day, that's still going to be 1 over 2x. So if you viewed it like this, again, it's just going to be a vertical compression by a factor of 2. So if you want to think about it that way, you could say that, okay, for this given x value, you see that here, this is 1, 1. Well, when you look at that point here, Well, now for that same x value, the y value has been cut in half. The y value is now 1/2 or 0.5. Again, an alternative way to think about it. Which answer is more correct? Well, whichever way you want to view it. In this particular case, I just chose to go with thinking about things horizontally. But in this case, if you wanted to do a vertical compression by a factor of 2, or again, a vertical shrink by a factor of 1/2, if you want to say it that way, that would be a correct answer as well. All right, for problem 6, we have f of x equals x cubed, and then g of x equals 1/4 x cubed. All right, so again, thinking about this is on the outside. So let me just write this as g of x is equal to 1/4 times f of x. And again, there are other ways to think about it and other answers that you can get, but I'm just going to go with this because that's the way it's presented to us. So this right here is going to give me a vertical compression by a factor of 4, or again, you could say a vertical shrink by a factor of 1/4 if you want to do that. Basically, for a given x value, you're going to get a y value that has been divided by 4 or multiplied by 1/4. So I'm going to say there's a vertical compression by a factor of 4. So again, if you want to look at this graphically, this guy in green, this is f of x is equal to x cubed. And this guy in, let's just call it red again. So this is g of x is equal to, let me make this better here. This is 1/4 x cubed. So all we're saying is that for a given x value, the y value is either divided by 4 or multiplied by 1/4. However you want to think about that. You can just take this point right here, which is going to be 2 units to the right, 8 units up, so 2, 8, 2, 8. Well, if I want that same x value, so of 2, on this g of x equals 1/4 x cubed, well, now the y value has to be divided by 4, or you could say multiplied by 1/4. Well, 8 divided by 4 is 2. So now I get that 2, again, same x value, comma, 2. Again, 8 divided by 4 is 2, so 2, 2. So that's why we say it's a vertical compression by a factor of 4. All right, for problem 7, we have f of x equals x squared, and g of x equals this 3x, again, this is inside of parentheses, being squared. Again, we're going to go with the way that it's given to us. And so this is on the inside. Again, it's being plugged in for x there. So in other words, we can say that g of x is equal to f of 3x. Again, there's other ways to look at this. I'll do that on the graph. You could say g of x is equal to 9x squared, but again, that's not how it's presented to us, so we're going to go with it this way. This is on the inside of the function, so we need to undo multiplication by 3, and to do that, we can divide by 3 or multiply by 1/3. So I would just say that there's a horizontal compression by a factor of 3. Again, if you want to use different terminology there and say there's a horizontal shrink by a factor of 1/3, that would be right as well. Let's come down here and let's label this. So this guy right here in green, this is our f of x is equal to x squared. So we know the points here. You have 0, 0, you have 2, 4, we have 3, 9, so on and so forth. And let me just label this point right now because we're going to use it. So this is 3, 9. And then this graph right here, again, let me arrow to that. That is going to be your g of x is equal to, we had this 3x inside of parentheses being squared. Now, I know a lot of you are going to say, well, that's the same thing as g of x equals 9x squared. So you really could say that g of x is equal to 9x squared. So I'm going to give the answer as a horizontal compression. You could also look at this as a vertical stretch by a factor of 9, but I'm going to do that at the end. So right now, let's just focus on this point and this point. So this point right here, maybe I'll arrow to it from all the way over here. So this is going to be 1, 9. So 1, 9. So to get that same y value of 9, notice how this x value here of 3 got divided by 3, or you could say multiplied by 1/3. So that gave me this x value of 1. So you get 1, 9. And again, it's just all about undoing what's being done to x when you're on the inside. If I did g of, let's say we plug in a 1 here, this is going to be, well, you have this 3 times 1 squared, which would be what? Well, 3 times 1 is 3. So this becomes 3 squared, which gives me 9. So the x value of 1 is now giving me a y value of 9, whereas in the original function, the x value of 3 is giving me a y value of 9. Now, let's look at it the other way. So some of you are going to look at that graph and say, hey, this is being vertically stretched by a factor of 9. And again, if you want to give that as an answer, it's fine, but I would just go with the way that it's presented. So if it's given to you this way, well, then you could take a given point. So let's say we take something like this right here, which is 1, 1. And I take that same x value of 1, and now I multiply the y value, which is 1, by 9. So that's going to put you up there. So you have that same x value of 1 corresponding to a y value that's been multiplied by 9. So 1 comma 1, that's going to go to 1 comma 9. If you want to give the answer as vertically stretched by a factor of 9, it's not wrong. But again, I always try to stay consistent with the formulas that are given in the book. So if I see something plugged into the inside, that's how I answer. All right, for problem 8, we have f of x is equal to the cube root of x, and then g of x is equal to the cube root of 2x. So what I'm going to do here is say that g of x is equal to f of 2x. So it's going on the inside. So how do I undo what's being done to x? Well, I would multiply by half or divide by 2. So I'm going to say there's a horizontal compression by a factor of 2. Or again, if you want to say a horizontal shrink by a factor of half, that's fine as well. So once again, this guy in green, this is my f of x is equal to the cube root of x. And then this guy in red, this is my g of x is equal to the cube root of 2x. Now, if you think about a given point here, so let's say we look at this one right here, which is 8 comma 2. So the cube root of 8 would give me 2. If I look at that point over here, well, again, now the x value is going to have to be cut in half, or you can say divided by 2 to get that same y value. So instead of an 8, divide that by 2, you would get 4 to get that same y value of 2. So this would be 4 comma 2. Again, if you plugged in a 4 there, where you're multiplying it by 2, that gives you 8. So you're right back to where you would be here, and then the cube root of 8 would give you 2. You have to be able to undo what's being done to x. And here, when we're multiplying by 2, if we want to undo that, we need to divide by 2 or multiply by half. All right, for the next few problems, the instructions are going to change. Now we want to find the transformation from f of x, this is going to be the graph in blue, to g of x, this is going to be the graph in orange. So this will be for problem 9. So this is the graph in orange. This is our g of x function. And this is the graph in blue. This is our f of x function. Now, first off, it's pretty easy to identify the function. So if you look at this one right here, you should know from previous lessons, this is the square root function. You have a point that's 0, 0, you have 1, 1, 4, 2, 9, 3. So this is f of x equals the square root of x. So now when you think about this right here, we'll notice that for a given x value, the y values are multiplied by 3. In other words, if I look at this point right here, this is 1, 1. Well, this point right here, this is 1, 3. Same x value, y value has been multiplied by 3. This point right here is 4, 2. This point right here is going to be, again, same x value, y value is multiplied by 3, so 2 times 3 is 6. Then for this one right here, you have 9, 3, so 9, 3. And then for this one right here, you take that same x value, so that's 9, and you multiply the y value by 3, so 3 times 3 is 9. So we could write this g of x function as being equal to 3 times your f of x, or just 3 times the square root of x, like that. In other words, we have a vertical stretch by a factor of 3. So a vertical stretch by a factor of 3. In other words, for a given x value, the y value has now been multiplied by 3. Here it's 1, 1, here it's 1, 3. Same x value, y value is multiplied by 3. Here it's 4, 2, here it's 4, 6. Same x value, y value has been multiplied by 3. Here it's 9, 3, here it's 9, 9. Same x value, y value has been multiplied by 3. All right, let's take a look at problem 10. All right, this one, you might not know the graph of it, but I've done it a lot in the various lessons that we've talked about at this point. This graph in blue, again, this is your f of x. So this is f of x is equal to, this is x cubed minus x. Then this graph in, let's just call this orange. So this is going to be your g of x here. And I just want you to look at the points here so you can get an idea of what's going on. So this right here is 2, 6. So 2, 6, if you need to plug in, 2 cubed would be 8, minus 2 would be 6. In other words, f of 2 is equal to 2 cubed minus 2. So that is 8 minus 2, which is 6. So that's where that point's coming from. If you look at the point over here, you'll notice that the y value of 6 is the same, but the x value is now 6. So this point right here is going to be 6, 6. So at first glance, we see that this guy right here, the x value has been multiplied by 3. So that's a horizontal stretch by a factor of 3. Horizontal stretch by a factor of 3. Let's look at this point and this point. So here you plug in a 1 and you get a 0. In other words, f of 1 is equal to 1 cubed minus 1. That 3 could be a lot better. 1 cubed is, of course, 1. So you get 1 minus 1, which is 0. Over here, you see that you get 3 comma 0. So again, the x value has been multiplied by 3 to get the same y value. This right here is 1 comma 0. And then this right here is 3 comma 0. And you could do these points over here if you want. It's the same thing. Maybe we'll do this one. We can just skip that one. Let's just do this one. So on this guy right here, it's negative 2 comma negative 6. And over here, you just multiply that x value by 3. So negative 2 times 3 is negative 6. So that point becomes negative 6 comma negative 6. So same y value of negative 6. The x value has been multiplied by 3. So that's a horizontal stretch by a factor of 3.